Hello and welcome to an episode of The Central Equilibrium. I'm Eric Kai, the chemical statistician, and I'm pleased to welcome my guest, Benjamin Garden, who will talk about simple interest versus compound interest. Ben, welcome to The Central Equilibrium.
Hi Eric, thanks for having me.
Tell us about your educational background.
So I have a master's and an honors bachelor's degree from McMaster University in social sciences.
Excellent.
Yeah.
And what's your current occupation?
So currently I'm a senior research analyst at Environics Analytics. And in my personal life, I'm an investor, so I invest my own money, manage my own money. It's something I've been doing for kind of my whole life. So
excellent. And how do you share your passion about investing with the rest of the world?
So since it's been something I've been doing forever, I just recently decided to start a website. So a couple years ago, I started a website, benjamingarden.com. It's just a personal finance website. It's kind of all the tips and tricks and the lessons I learned growing up. And I also have an Instagram that I do videos every Monday, Money Mondays, and talk about it like that.
Excellent. So I'll make sure to put down Ben's website and Ben's Instagram account in the description of the video in the show notes down below. Okay. So Ben, what's your objective for today's episode?
Okay, so I want your viewers to learn two things. I want to emphasize the power of compound interest, and I also want them to understand how they can implement it kind of right away in their personal finances.
Excellent.
To help them.
Excellent. Okay, so I think before we talk about compound interest, which is really where the magic happens, I think it would help if we start with what simple interest is. So shall we do that?
Yeah.
Excellent. Okay. So I'm just going to erase the board so that you have a little bit of room to write, more room to write, and then why don't you start by telling us what is simple interest?
So simple interest is a type of interest. Interest itself is it's the privilege to borrow money. So let's say I lend $100 to Eric. Because of the lost opportunity cost of that money, I should get something back in proportion to the money that I lent Eric for a certain time frame. So simple interest is a very simple and quick way of calculating that interest due, and it's usually it's the principal multiplied by the interest rate multiplied by the time frame.
So I think that the key thing that we need to note about simple interest is that it is calculated solely on the principal. Right. No matter how much the amount of money grows in the future, the interest is calculated solely on how much was borrowed in the very beginning. Right. Okay. So Ben, why don't you show us an example of a calculation involving simple interest?
Okay. So I'll just write down the formula so we have it here. So it would be A, which is the total accrued amount of principal plus the interest dollars earned. So A equals to P times 1 plus RT. And so A is the total accrued amount. P would be the principal. 1 plus R would be the interest rate, typically represented as like per year, but the time frame can change, and T would represent the time frame that interest rate is it exists for. So it's important that R and T are consistent in terms of the time units that we're talking about. So if we're talking about years, the interest rate should be, for example, 6% per year, and then the time frame would be how many years did I lend that money.
That's a very good point. You know what? I think it would be good if we write what you just said out on the board. So A is the accrued amount. P is the principal amount. Yeah, it's probably best if I use that black felt pen here. Okay, and R is the rate of interest. And T is the time period. Okay, and so as Ben noted, it's really important for the rate of interest and the time period to have consistent time units. So if we're going to define the rate of interest in terms of years, then the time period needs to be expressed in years. If we define the rate of interest in terms of months, then the time period needs to be in months for this calculation to work. Okay, so that's the formula for simple interest. Ben, shall we plug in some numbers to illustrate how this formula works?
I think we should. Do we have it here at the bottom?
You know what? We'll erase this.
Okay.
So. Okay. Go ahead.
So I wanted to pick a realistic example, and while we can always talk about different interest rates, like as high as 10% or as low as 3% or whatever, we settled on 6. So we're going to use an interest rate of 6%.
Mm-hmm.
Now, so this example, we're going to say that somebody starts investing at the age of 25,
mm-hmm.
and they retire at the age of 65.
Mm-hmm.
So that's 40 years. 40 years where the money is invested and grows at 6%.
Mm-hmm.
So interest rate 6%
per year.
Per year.
Yeah.
Yeah. Per year. And the time frame that we're talking about is 40 years.
Okay. Okay.
So let's plug in these numbers. So we're solving for A in this case.
Mm-hmm.
So the principal, oh sorry, I forgot to mention what the principal amount was, how much we're actually investing.
Right.
So the principal in this case is going to be $10,000.
Okay.
So we're going to invest $10,000 at 6% interest per year for 40 years. And how much would we have at the end? That's kind of what we're going to solve for.
Yeah.
So the total accrued amount would be the principal of 10,000 multiplied by 1 plus the rate of interest, which is 6%, which we can write as 0.06 multiplied by the time frame, which is 40 years.
And we need just another bracket just to close that off, Ben.
You're right.
Yeah.
I thought that was a 1 for some reason.
No worries.
So if you solve for this, you would, what did you get? 34,000. So at the end of 40 years, you would end up with $34,000, which, as you can tell, is an increase from the $10,000 we initially invested. So this is $10,000, including the interest money added on top.
Right. So that's pretty decent. Eh? Your money more than tripled over the 40 years.
Yeah.
Based simply on simple interest.
Right.
Okay. But of course, in real life, money does not grow on simple interest, especially if you invest it wisely.
Right.
Oftentimes, money grows based on compound interest. So Ben, why don't we now talk about what compound interest is?
Okay, so in terms of compound interest, let me remove this. And I'm just going to write the equation underneath the simple interest so we can compare it.
Sure.
So you notice that's mostly similar except for we're taking the rate of interest, we're dividing it by this new variable n, and we're raising that to the power of n t. T is the same t. So the new one here is n, and n is equals to the number of times so n in this case represents the number of times that the interest rate is compounded for the time period of t.
Okay.
So for example, if it was compounded once per year, this would just be a 1. If it was compounded twice per year, 2.
Right. And it's the number of times it's that this interest is compounded per time period.
Right.
Right. So let's just make sure we clarify this for everybody here. So this is the formula for simple interest. And this is the formula for compound interest. Okay. I think it might be helpful to clarify that n here is per unit of t. Right? So let's say if t is 40 years, n is the number of times that the interest is compounded per year of t. Right?
Right.
Right. Okay. Sorry. If I could just borrow a pen here. Okay. So we'll just clarify this per unit of t.
Right.
Okay. So yes, actually, so we're going to continue on with our example earlier. So if everybody remembers from that example that Ben just covered, we're starting with $10,000.
Right.
We're going to grow it at 6% interest, but compounded. And we'll make it simple. We'll say that it's compounded once per year,
right,
but we'll still grow it for 40 years. So Ben, why don't you take us through that calculation and show us how much the accrued amount would be over 40 years based on compounded interest at 6%.
Okay, so I'm just going to punch those numbers in here. So I'm still solving for A. Compounded once per year, so we're just divided by 1. And again, once per year, but we're doing it for 40 years.
Mm-hmm.
So, I'm going to refer to my notes because I don't
have
a calculator.
That's all right. That's all right. we're prepared.
Are you ready for how different this is going to be?
This is really the magic of compound interest right here.
Yeah. And that's the thing, is that this is, if you recall, the value that we ended up with for simple interest was 34,000.
34,000.
And now we're talking about 102,000, etc.
Mm-hmm.
So more than triple what we had for simple interest.
Mm. Yeah. Right about, yeah. So this is, it's not magic in the sense that the math is pretty straightforward, but it is magic how if you start with just $10,000 and you save it and you invest it at 6% is, I'd say it's a pretty moderate.
Yeah, 6% is a
figure,
yeah.
Right? And you just leave it for the I would say 40 years is an average duration of how long somebody works for, right? At the end of that working period, you're going to end up with more than 10 times of what you started with, which is really astounding. So I think this is partially a math and finance lesson, but it's also about the importance of investing your money early,
right?
And having the discipline to not take it out during these 40 years, and just letting compound interest work its magic over time, so that you'll end up with a really nice nest egg.
Right, exactly. Yeah, and that's the thing. If you notice, so you play around with the different numbers, which I encourage you to do. If you play around with the time frame and the percent, you can really get some interesting numbers coming out. Yeah,
and let's just make this just a little more complicated. Let's suppose that we are compounding this twice per year instead of once per year. Then, just to, excuse me, thank you, Ben. Just to show you how the math works. So if the interest is compounded twice per year, then you simply substitute 2 for n down here in the denominator, and also n here in the exponent. And this turns out to be, and I encourage everybody to do this at home, 106,408.91. So as Ben suggested earlier, it's a good idea for everybody at home to play around with these numbers, the interest rate, the number of times it's compounded, the number of years that we're using to grow this investment, just to see what you have at the end, the different variations of this result. Okay.